Hello everyone and welcome back to Savvy Market, where we turn data into actionable insights. In this particular lesson, we are going to learn how we can use Microsoft Excel data analysis tool pack to perform a correlation test. So the correlation analysis is used to find any relationship between two numeric data. You can see that we've got the numeric data like quantity sold and sales. And the purpose is to find any possible relationship between these values and also to measure whether the relationship is statistically significant. So for this, we'll be having a null hypothesis as there is no significant relationship, and the alternative hypothesis will be that there is a significant relationship. So we have already identified the required test, which is the correlation test. But to prove the requirements of this particular statistical test and to perform the analysis based on the given data, we need to perform two assumption tests. First, we are going to check the normality of the two variables by visualizing the data with the help of the histogram of the corresponding variables. So at first, we'll select the quantity sold variable. So select the quantity sold variable, then proceed to the insert tab, and then go over here where we have statistical, and then we click on histogram. So by checking the distribution, we can accept the normality because the distribution is near normal. So we can conclude that this distribution is a near normal distribution for quantity sold. So that is what we are going to have as our chart title, near normal distribution for quantity sold. So we have our title for the histogram, and you can remember from our previous lesson we have identified that the sales also follows a near normal distribution or normal distribution, so we are not showing the histogram of the sale variable. So then we can proceed to check the linearity between these two variables, and you know that the most appropriate measure of checking the linearity is to plot a scatter plot and adding the trend line. So we add the trend line to see whether there is a positive or negative linearity or no linearity at all between the variables. So we are going to select both the variables now, that is the quantity sold and the sales variable. Then we proceed to the insert tab and we are going to plot our scatter plot. So we proceed to the insert tab, and then over here where we have scatter, then here we click on this one. So here you can see the output of our scatter plot, but data is not providing us with the actual linearity, because as you can see there is no trend line. Let me quickly take this here. So what we have to do is to right click, that is with the help of our mouse, we'll right click, and then where we have format, so for you to get the trend line, as I said, you right click your mouse, and then you will see options to add trend line. Then you select it, and here you can see a trend line has been added within this particular graph, and you can see the trend line is going lower to upper. So we can say that there is a minimum linearity, a positive linearity within the variables sales and quantity sold. You can name the title as minimum positive linearity for sales versus quantity sold, as I have named mine. We have tested our assumption, and based on the assumption results, we want to test the correlation analysis for two numeric data, that is for the quantity sold and sales, to find the relationship between them. So to do this, we have to proceed to the data tab. And then you are going to click on data analysis option, and here you can see the correlation option. So you have to select it and click OK. So first of all, you will provide the input range. So to provide the input range, you have to select the quantity sold and sales variable and drag it down to select the entire information. You can see here along with the variable name and their values. The next thing is that you have to check where you have the labels in first row. You have to check that as well, and you can see there is no option for us to provide the value of alpha, that is our significance level. So in this case, we are following the 0.05 significance level. We have to calculate, we're going to calculate it manually. I'll show you how to do that later on. So first we have to provide the output range, where to place the output. So you select the output range and where you want to plot the results. So anywhere you want to plot the results, you just click on that particular cell, and then you hit OK. So when you hit OK, you are going to have these results that we have over here, and then you can head to the home tab and select the number format so that everything will be just the way it looks here. You change it from the general format to the number format. So you can see the correlation coefficient between the quantity sold and sales variable is 0.22, which is a positive value. So we can see that there is a positive relationship between sales and quantity sold, and then you can see the correlation coefficient is below 0.5, which is our significance level. So we can denote the relationship as a weak relationship. So in essence, we are going to say that there is a weak positive relationship between quantity sold and sales. But the question is whether the relationship we have just found is statistically significant. So to measure this, we have to find the p-value, and to find the p-value, we have to calculate two additional values. First, we have to calculate the degrees of freedom. In short, that is degree of freedom, we have it as DF for short. So to calculate the degree of freedom, we have to first calculate the total number of counts of observation within this particular given data. So to calculate the count, we have to use the count function. So first of all, we'll assign the equal sign, and then we call up the count function. So we select it, and now we proceed to our data, and we want to select any of the variables observation. So suppose we want to select all the observation of sales. We want to select from the first to the last. So let's say we want to select sales. So this is the first, and then we go Ctrl plus Shift downwards arrow. So we have been able to select the sales variable from the first value to the last value. So the next thing that we'll do is to provide the closing brackets for the function, and then we have to provide a minus sign, and then we have to subtract the value 2. So calculating degree of freedom is actually subtracting the number of variables you have from the 2. So after this, we'll hit enter. So as you can see, our degree of freedom is 98. So the next thing we want to do is to calculate the t-statistic. And to calculate the t-statistic, as you can see over here, we have a formula. So here we're going to have t-statistic we have to follow this particular formula, this one over here, for us to be able to calculate the t-statistics. You can see that it includes the R, which indicates our correlation coefficient of 0.22. So the first thing we have to do, as always, is to put or rather assign our equal sign, and then in this particular cell, we are going to select where we have our correlation coefficient. That is on this particular cell, this is L11, or rather L9, sorry, L9. That includes the value 0.22. Then we have to provide a multiplication sign. So we have to provide a multiplication sign, and then we have to take the square root of the degree of freedom. So you can see in this equation that we have over here, it is the square root taken for the n-2, and here n indicates the total number of observation and 2 indicates the value. So the n-2 is actually the degree of freedom. So we can replace the n-2 by the value of our degree of freedom, which is 98. So at first, we are going to provide the square root function in our formula of calculating the t-statistic. So we are going to search for squared. So it is spelled as SQRT. So we select it. You can see the function here, and we've selected it, and now we have to assign the value of degree of freedom that we have just found by subtracting the value of 2 from the total number of observation. So we select the particular cell that includes our results for degree of freedom, which is L10. Now we want to provide the closing bracket. We'll provide the closing bracket, and we have to provide a slash sign to divide the results, and then we have to call the function square root, because you can see in our formula the square root is called again. So we'll call up the function square root again. So we select it. So the next thing we want to do is to provide the value 1, then minus 1, then minus, and we have to now take the r square, or the square root of our correlation coefficient of 0.22. For this, we want to provide a bracket. Sorry. So when we have our r, remember our r is here when we have our correlation coefficients. So the next thing we'll do is to provide a closing bracket. Then we want to provide the cell number that includes our r, which I have done already. So after that, the next thing we want to do is to provide this superscript sign, and now we provide the value 2, and then this portion in this particular formula actually indicates the square of the value 0.22, or the r square. And now you have to provide the closing bracket and then hit enter. So here you can see the t statistic value, and then now we are going to calculate the p-value in this particular cell. So we are going to have the p-value over here. So to calculate the p-value, we have to assign the equal sign in this particular cell, and then we'll use the t dot. I'm going to use the t dot distribution dot 2t. You can see it over here, so we select it, and then we have to provide first the x, which is the value of our t statistic. So we'll select the cell that includes the value of our t statistic, that is L11. That is where we have our t statistic. So after that, we'll provide a comma sign. And then we have to provide the value of degree of freedom, which is 98. So we select the cell where we have our degree of freedom, which is L10. Now we'll provide a closing bracket, and then we hit enter. So you can see the p-value. We can see our p-value. So we want to keep it in a numeric format. So to keep it in a numeric format, I will equally do that for the test statistic as well. So we select that, and then we head to the home tab, and then here we want to change this from general to the number format, so you can see our t-statistic and our p-value. So that is all. The next thing is that we have our p-value at 0.03, and you can see that it is lower than our significance level, which is 0.05. So as per the p-value calculated, we can say that the positive but weak relationship between sales and quantity sold is significant, or rather statistically significant. And now we can go ahead and then make our decision. We are going to say that we can reject the null hypothesis and accept the alternative hypothesis, and our conclusion is that there is a weak positive relationship between quantity sold and the variable sales. So this is how you can perform correlation analysis by using the data analysis tool pack and the different formulas that we used, that I just showed you with the help of Microsoft Excel. So we've come to the end of this lesson. If you did enjoy it, please do not forget to give it a thumbs up, and also do not forget to subscribe. And if you know anyone that this video will be helpful to, please do well to share it to them. If you have any questions, please leave them in the comment section below, and I will attend to all of it. Thank you, and I'll see you in the next video.